the 10:30 at night start time. Hi, Phil. Alrighty.
Hey, Phil.
That's nice of Phil to join. All right, guys. So just as we're getting started, I'm going to throw up a poll for what you all think about the moon. All right, guys. So, oh no, there we go. Okay, so I'm going to ask you guys, we're all going to ask you guys if you saw the supermoon last night, and then we have a trivia question for anybody who's here. Can you guys see the poll yet?
Yeah. Well, I'm
okay.
I can certainly see it.
I didn't let you guys
allowed to vote.
Ryan and Sarah. Sorry, I did.
I can't
Tragic,
vote.
but I know all the answers.
I would be horrified if you didn't, Ryan.
It's wise, yeah.
So if you guys want to vote, there's a trivia question, and then there's a general how did things go last night for you while you were observing question. Wait, no, you guys are both in Toronto, so none of us saw the harvest moon. None of us saw the moon last night, the supermoon, eh?
No supermoon for us.
Too bad. Did you see it tonight?
No. Did you?
No, I didn't leave the house.
Yeah. I just peeked over out the balcony too, and it still seems cloudy.
Oh yeah?
At least where I am.
Oh, too bad. Alrighty. I'm gonna end the poll because we've had a whole minute to vote.
Wow.
And let's see how people did. Actually, so interesting. I'm gonna share the results so everybody can see them. Here we go. So we kind of tricked you guys on the what's the full moon in October called. So the harvest moon is a good guess. The harvest moon is actually September.
I didn't actually see the results. What was the?
Oh, are you not seeing them now?
I am not.
Question.
It's tragic.
Oh, I'm so sorry. It's because you're so I'll verbalize.
You could tell me. Yes, you could use your voice.
I'll use my words because people on YouTube wouldn't be able to see either. So only less than 50% of people saw the supermoon last night, but only just barely 48%. So that's pretty good. And then what's the full moon in October called? 74% of people said the harvest moon, and you guys are so close because that is September. And then
that was a curveball.
Yeah, it was a curveball. 22% got it right, which is it's the hunter's moon. So
well done.
Yeah, good job, everybody. We're going to talk about a whole bunch of different moon things tonight. The naming of the moons, like harvest moon, hunter's moon included. And tonight we have Ryan and I, who are standard normal people, but we're also pretty great. But the really important person.
That's how I describe myself. Standard normal person. Cookie cutter, human being.
The perfect example of a person.
Yes. But we have a super person.
We have a super person because she has a PhD
Supermoon.
and is very smart, and her name is Sarah Missouri. I don't think I've ever tried to pronounce your last name. I just always
got it.
Did I get it?
Yep.
Nice. I should have tested that beforehand. Sorry, everybody. So Sarah has done her PhD on lunar craters, and the extra fun thing is that all three of us worked at the Ontario Science Centre together.
At different times.
At different times, yeah. Sarah, were you there when Ryan was there?
Yes, briefly.
Very briefly, like tiny overlap?
Yeah, very briefly.
Yeah.
Oh, man. And I was there for 5 years, too, and there was still that tiniest little overlap, but
yeah.
It's a great place for great people to get together, right?
It is for sure. Mm-hmm. And Ryan and Sarah are both far more accomplished than I am because both of them have multiple degrees in space things, and I'm a marine biologist, but I'm here for fun.
And
you're far more accomplished.
And an astronomer and a great science communicator. Should I go on and on?
A far more accomplished marine biologist than either of us.
Yeah,
so.
That's true. I can tell you a thing or two about Cetus the whale, but we'll get there another time. Anywho, so we're gonna start off talking a little bit about the full moon last night. So for those of you who did see it, it was a supermoon. And can one of you two explain so that my sleepy brain doesn't have to, what a supermoon is, please?
Super Sarah, I'm gonna let you do this. Super scientist Sarah.
Super scientist Sarah. Do we want to do do we have an option to get the audience to sort of come in as well? Do we want to do that a little bit?
I can either create a poll or we can get you guys to all talk in the chat. What would you prefer?
I don't know.
Let's get people talking in the chat because polls take a little longer to set up.
That's always a good idea.
That sounds good. We'll just read a couple of them and then I'll tell you what the supermoon is.
Yes.
It's when the moon is really big. Yeah, kind of. It is pretty big. There are 2 full moons, October 2020, and then October 1st and October 31st. Yep. Someone's giving a hint.
Cool.
Perihelion. Yep. What else?
Anybody have any ideas what the supermoon actually means?
Well, people are saying things. I'm going to moon everyone.
Oh my goodness, Ryan, that was perfect.
I've been waiting like an hour to say that. So there you go. Wow. This is me mooning everyone.
So yeah, a supermoon is either a new moon. It could be a new moon or a full moon. I think the full moons are cooler just because you get to see them. And it's when it's at the perigee, or somebody said perihelion, perigee. So pretty much when it's at its closest orbit around the Earth, because it's not a perfect circle. It's kind of elliptical. So at some point or another, it's going to be slightly closer, 3,000 miles to the Earth than others. So that's how we get a supermoon.
And correct me if I'm wrong, but it has to line up with either the full moon or the new moon, right?
Yes.
If it's in between, it doesn't count.
No, not that I know of.
That makes sense. I don't think it would. Like, no one's saying there's a supermoon, but it's only a quarter.
Yeah, it's like a crescent supermoon.
Yeah, I mean, the average distance to the moon is about 384,000 kilometers, and that does vary by about 20,000 kilometers, give or take. So micromoon is the smallest one, supermoon's the biggest one, but it's not a lot bigger or a lot smaller, but the brightness change is what you really notice whenever you see a supermoon up in the sky. It's just so much brighter because you're getting more disk area, right? Just by growing that much bigger, you get a lot more brightness out of it, basically. So you notice it.
That's what to look for. And unfortunately, last night's was the last of the season, so we won't, or last of the year, sorry. So I don't think we're getting another supermoon for a little while, but it's definitely something to look for next time. Yeah. How do you guys feel in general about, so technically, I don't know, I think there is the technical term where the moon is at perigee, and you can use those sort of scientific terms. How do you feel about terms like supermoon and mini moon and stuff like that are sort of a little bit more unscientific, but get folks interested?
That's a great question. I don't like them, but I have to say I've warmed up, because to me, anything that gets people talking about space or science is worth it. So fill your boots. You want to call it a supermoon? I will tell you scientifically what that means. But there's not a huge difference. Like for me, that it's not super. The moon's always pretty super to me. So I don't see a huge difference. So I'm happy that the terms are out there and getting people excited, but it's not really helping me at all.
That's fair. Sarah?
Well, I mean, I always call it the super cool moon. Like I say cool a lot whenever I talk about the moon. So it is super cool. Oh, hi, cat.
That's Aries.
Aries, because your cat has space names. Both of you have space named pets, and it makes me so happy. Anywho.
Yeah, I mean, I don't mind the supermoon and the mini moon. But I get very confused with like blue moon and pink moon, and when like colors start to come in, that like throws me off a little bit. Whereas like super and mini, it's a little bit to do with distance. It's not as extreme as we would think. And I feel like in my first, big thing of getting into astronomy was when Mars was going to be at its closest in like 2003. And I'm like, oh my God, it's going to be as big as the moon. And like, I lined up to look through the telescope, and it was just like that dot. So it is, when you hype it so much, it does get a little disappointing sometimes, but I don't mind the names as long as, I don't know. I mind the colors a little bit. They confuse me.
Yeah, the colors and the extra names, often they have like a different background, but they do, when there's things like pink moon, blue moon, which I know is not necessarily to do with the season, and we can talk about blue moons in a minute, but those confuse the general public too. They see that and they're like, the moon's going to be pink, or the moon's going to be blue, or the blood moon even, the blue moon's going to be red.
Yeah.
And it's sort of like, I mean, it does get people interested, which is great, but it sometimes kind of messes up the science side of it too.
Well, sorry, I'm going to go off topic because I want to answer this question in the chat. A couple of people have mentioned, how often is the moon in its perigee? And the answer is really once a month. I mean, the perigee is the closest point in a particular orbit. So you can say at any given month, the moon is going to be at one point where it's at its closest and one point where it's at its farthest. You can also say, well, there's the supermoon might be when the perigee lines up with the full moon, right? That's what we're looking for. Not only is it at its closest point for the month, it's at its brightest for the month, the full moon. And then of course there's been, I think last year or the year before, there was one that they called like a super moon or something, extra names and everything.
Did it have some
and
color too? I think it had some color too.
Probably. Yeah. Super blood blue moon, whatever. Yeah. Super blue moon. It was a super blue moon.
Yeah.
And it was the perigee, the closest point the moon was to the earth for the entire year that happened to be a full moon. And also a blue moon, which I think will lead us into what Jenna wants to talk about next. So there you go. So perigee happens basically every month.
Yeah. Okie dokie. But it doesn't always line up with the same phase every month because the moon is orbiting.
Correct. Yeah, correct.
And then that was it. There's the term from Phil, super wolf blood moon, which was January 20th or 21st last year because it was minus 40 degrees and I had to stand on the roof of the York Observatory's parking lot. And then just a question before I get into blue moons, because that's a sort of, we'll diverge a bit. This is more of an opinion question. Has there always been this hype about the moon, or is this recent? I don't recall all these terms when I was younger. I don't recall the terms either. I think the sort of clickbaity stuff is a newer phenomenon.
Supermoon as a term has been around since 2014. It was definitely after I started at the Science Center. So that's about when it was that I remember doing media, and they were like, "Oh, have you heard about this supermoon?" I'm like, "What? Why are they calling it that?" And here we are.
Did a bunch of people meet and decide, okay, we're gonna start calling this like the supermoon from now on?
It just, if it's one or two people who's trying to come up with a hypey name to get some clicks, to get some news, and it just takes off, and then now it's probably in the dictionary.
Probably at this point.
Yeah.
I'm gonna switch to gallery view so that we can all see each other at the same time. Ryan, if you ever want to stream your screen or share your screen, just let me know, and I'll switch us back. Or it'll switch us back on map.
I will. I'm gonna moon you.
Thank you for that.
You're welcome.
It's just the time of night where I find these sorts of things funny.
Excellent.
And then one last question to why is the moon larger by the horizon? This is just a.
I feel like I just had this conversation recently with my husband, and then I had to like Google it, and he's like, "Shouldn't you know this?"
It's just a visual thing, though. It's not like a super.
I said it's an optical illusion, and then we had this whole like discussion of like, but that doesn't make sense because it's a lot bigger, and like what kind of optical illusion? And Google wasn't really helpful because it's an optical illusion, and I couldn't really explain it a lot better than that. So I tried to give some examples.
So we actually talked about this, a couple of us yesterday, and it's to do with when the moon is near something that you're used to seeing for perspective. It looks larger, and then when it's up in the sky, you don't have anything beside it to compare the size to. Something along those lines. Yeah, it's a funny one. And now I'm going to pause on the questions from folks. And we're going to talk about blue moons just briefly, because a lot of folks don't know what blue moons are. Anybody in the chat, what is a blue moon? Anybody know?
That's good.
There's a song about blue moons. I'm not going to sing it and embarrass myself.
I was going to say, do you have your ukulele to like sing?
I do have my ukulele, but I do not know how to play Blue Moon. Darn, what a shame. I know how to play Mr. Moon. It's very cute. So we got a couple answers. Second full moon in a month, which is a very good answer. I think, never mind. I was about to add something, but it's done. It also means 4 blue moons in a season, which inherently means that there's one more in a month.
So I actually was doing some research on this the other day. And that the idea, and what I thought for a long time, was that a blue moon is when you have 2 full moons in a calendar month, right? So you would have one at the beginning of the month and one 29 and a half days later. So you can have 2 in a calendar month. But that was actually an error made in an issue of Sky and Telescope in 1946. The true definition of a blue moon is 4 full moons between an equinox and a solstice, or a solstice and an equinox. So the the time between a solstice and an equinox, or an equinox and a solstice, is 3 months. So you would have to have 4 full moons in those 3 months. And so technically 2 of those would have to fall in a calendar month.
However, wait, if it goes from December 21st to March 21st, you have December, January, February, and March to play with. So you could have one.
Yeah, you're right. You're right. You do. So there you go. So that is the technical term of a blue moon. And so when somebody says once in a blue moon, 7 times in 19 years. So about once every 3 years.
Okay. All right. Make sure you get your frequencies right, folks. Don't do this willy-nilly. Okay, so the one other thing that I wanted to talk about too, which people have asked in the question, speaking of colors, is that this month's moon is the pink moon. And where do all these names come from?
Yeah, I know this one. I know what a pink moon is. I Googled it. I Googled it last year. I think a pink moon is the first moon of the spring. So it could be a first full moon of the spring. That could be in March or April.
That makes sense. That sounds right to me. Yeah. I always thought it was in April specifically, but that makes sense, especially if we're going
last year's was in March, and it was it also a blue moon? I think it was a blue moon and a pink moon, or a supermoon and a pink moon.
It's getting special up in here.
Yeah.
And Ryan, you have a good bit of information about why we have these kinds of names, right?
Oh, those names are fun. Most of them have roots with Indigenous Americans. So different Indigenous cultures have their own stories about what the full moon means each month. And I mean, people have had stories about the full moon for thousands of years because, hey, it's this big, bright ball of light in the sky. You're probably going to come up with stories about it. And so what actually happened was I've got the year here. It was in the 1930s. The Maine Farmer's Almanac in the US actually pulled together, they compiled all of those stories and they published them. And ever since then, when I was a kid, my parents used to get me the Old Farmer's Almanac because it had some space stuff in it. So I was like, oh, that's super cool. And I learned all those goofy names for I shouldn't say goofy. I always thought they were really fun. And so that's basically why they're popularized, was that the Farmer's Almanac, formerly the Maine Farmer's Almanac, published all of these older stories from Indigenous American cultures and put them all together, and that's how they became popular.
There you go.
So there are multiple ones. There's tons of them for each month. So like if we were talking about April, right? April is also known as the full moon in April is also known as the seed moon, the sprouting grass moon, the paschal moon, and the egg moon. And there's more. The fish moon, the frog moon, the spring moon, the awakening moon, the sap moon.
Wow.
Pick your favorite.
And Dave Chapman just chimed in. Actually, he's from Nova Scotia, and he was saying that it is specifically the birds laying eggs moon. So if you're,
super cool.
Yeah. So we were, Ryan and I were talking about sort of like the origins of the names, and that makes sense that the birds would be laying eggs right now. It is baby season. So that's where all those names come from. There's some really cool names out there, and it is, the moon is it's almost in every culture, right? It's the only, everybody can see it at some point or another, and it's super easy to find, even if you're in the Southern Hemisphere. There was another question from Dan Meek as well, this is kind of bringing us back to our origins here. Why do we have a moon?
Ooh,
yeah.
That's a great question. I love that. There is a leading scientific consensus about why we have a moon, and specifically why our moon is comparatively quite large. Like if you toward its parent. So our moon compared to the Earth is much bigger than any of Jupiter's moons compared to Jupiter. So our moon is much bigger relative to its parent. And so the idea is that when the solar system was young, it was just kind of forming. Sarah, you can probably answer this better than I can as a moon expert, but basically when the solar system was young, there was a Mars-sized object called Theia that crashed into the young Earth, which was probably a little bit bigger. And the debris from that collision formed this debris field that coalesced into the moon. And part of the reason we think that is that a lot of the same minerals are present in the crust of the moon and the Earth. So please correct me, Sarah, if I've missed anything on that.
No, you're pretty right on the ball. There was a very close competing hypothesis a few years ago, and I think they're still working on it. And it's pretty much the same thing. It's only about the size of it. So I guess the leading hypothesis is that the other object, or Theia, was pretty large and similar in size to the Earth. But there's another hypothesis that it could have been much smaller in size. It's just the speed that it would have collided with the Earth would have been different. But yeah, basically there was just a soup of stuff going around at the beginning of the solar system formation and things just bumping into one another. And that's how we've got our moon. But what I love about this question is that I'm always like, we still don't know the answer to that completely. And that's why it's still important to like learn about the moon. And, it's one of those things that we still don't know the basics of how our moon formed.
It's so cool that we feel like we're very smart people here on Earth, and we still don't know some of the total basics of stuff.
Yeah.
It's very cool. So there's two things coming from the comments. First of all, can Sarah share her research on dating moon craters? No, we invited her for no reason at all. She's not allowed to talk. No, we're going to talk about that later. We're going to get into that. We're just starting with the basic stuff, and then we're moving into the more advanced stuff because Sarah is very smart, as previously stated. And then the other question is, why were the phases of the moon at a different angle when I was in Jamaica?
I saw this, and I have an answer, but I want to let Sarah or you, Jenna, answer it as well, because I've got a good long answer, but I don't want to give it. I want to hear what you guys.
I just have a super basic answer of You're just seeing it from a different angle, and if you're in, like, let's say Australia, further south, you actually see it upside down. Well, upside down compared to here. If for more technical answers, please see the other two hosts of the show.
I kind of want to hear the long answer that Ryan's got prepared.
I mean, it's not that long. I wrote an article on this on my blog, like 2015. So I'm going to shamelessly post this and plug myself here. But basically, I was out one day waiting for a bus, and I was looking up at the moon, and I'm like, oh, why has the moon got that weird angle? It was a crescent moon as well, right? So I'm like, oh, why has it got this weird angle? And I looked at it and I thought about it, and I thought, well, what would it be like if you were somewhere else on the Earth? So I did some of the research on it and got photos from different people around the Earth of the moon, or saw photos from different people all around the Earth of the moon. And sure enough, the angle of the moon changed. And Jenna's answer is absolutely right, that you're basically looking at it from a different angle. If you imagine a person standing on the Earth, which is a globe, right? If you're standing in the northern hemisphere, assuming north is up, your head is pointing more or less up and your feet are pointing more or less down toward the center of the Earth. If you're in the southern hemisphere, your head is pointing the opposite direction, right? Toward the south, and your feet are still pointing toward the center of the Earth. So when you look at the moon, you see it what we would consider upside down, but the angle's different. Now, if you're at the equator, here's where it gets fun. If you're at the equator, the crescent moon is literally like, whoops, wrong way, literally like that.
Ooh.
Oh.
Like a little sailing ship or a banana.
Oh.
That's so cool.
Yeah.
Ooh.
Interesting. I was about to do a
just
demo.
in Australia last month.
Do a
and
demo.
Technically, these things, like, when you're in the southern hemisphere, the moon would look upside down. But like the first time I saw it, I'm like, why does the moon look so weird? Like, what? It doesn't look right. And I'm like, oh, it's upside down. That's so cool.
Sarah, were you weirded out by the sun being in the northern sky?
It was definitely weird. Yeah.
Mm-hmm.
Yeah.
That'd be very strange.
Mm-hmm.
Yeah.
Everything would feel very strange. Heather's saying, do the example, except I have never thought through this example. So I was like, I have a round thing. That could be.
Do it live. Yeah.
But I guess if this is the moon and we're looking at, let's say, the face of it that has the logo on it, which will have the arrow pointing up. If you're at the North Pole, I presume you would see that. And then if you're at the equator, your head would be tilted halfway. And so you would see that instead, right? And then if you're on the South Pole, it'd be like you're standing upside down and you would see that. Does that make sense?
Yeah.
You're standing on different sides of the sphere, which I'm not going to do.
Yeah, basically.
I have neighbors and they would be happy about that.
Come on, Jenna, put yourself upside down.
Can you please do the demo?
What can I hang from in here? Quick question from Allison. Would it be possible to ever lose the moon from our gravitational pull?
Sarah, you got this one.
I don't think so. I mean, the gravity on Earth is pretty strong unless, I mean, the only thing I can think of is unless something really massive bumped into it and just knocked it out of its current orbit. So even with satellites that we put up, they're pretty much in a good, nice orbit that can just have them going around. So I don't think we could lose the moon, just, wake up one day and lose it. And I don't think, even though things are expanding, it wouldn't be that much further out. Ryan's got a demo for us. So yes, I think unless something bumps into it, something really big bumps into it, probably not.
So I've always thought the moon was moving ever so slightly away from us.
1 centimeter per year.
1 centimeter per year. So if it's moving away from us, I don't know if we'd ever lose it, but I presume it's like having an overpowered satellite that we've given too much juice to, that's now moving further on its orbit. But I don't know anything about orbital mechanics, so that's really not something I have any authority to say anything on.
Sure you do. You know what? We would be talking to a layperson, Jenna. If a layperson was in your shoes right now, we would be talking to them the exact same way we're talking now. We're curious what you know just as much as you're curious what we know. So give your good ideas and your.
I thank you, Heather. Yes, Kat. I think, I don't know. I guess that, it might be able to, I honestly don't know enough about orbital mechanics. I have not played enough Kerbal Space Program or had enough degrees to figure this out yet.
So it does move away, right? It's moving away a little bit, like a centimeter a year. That is causing the rotation of the Earth to slow down. So the day's getting longer, the moon's moving further away. Eventually we won't have eclipses anymore. But the moon is falling around the Earth. So unless there's something that can change its momentum, it's going to keep falling around the Earth, as Sarah said. So
Dan and Brian, I see both your questions. We will get there. I do want to talk about eclipses because we talked about the abnormally large size of the moon, and eclipses are cool on Earth, especially because we have an abnormally large moon. And right before we do that, Babak asked, who is this beauty behind Ryan? So Ryan.
Just typing an answer.
Okay.
his name is Aries, and his sister is Venus, and she's a lot less friendly, so she's hiding somewhere.
And then Sarah will ask you about your moon craters and all that sort of stuff shortly, and then we'll talk about your dog's name.
I'm excited for that.
But quickly about lunar eclipses, because here we are, and solar eclipses. Can somebody, while I write down all these extra questions, tell me why it's so great here on Earth for lunar and solar eclipses? Well, solar eclipses specifically. Over to you guys.
I'll let Ryan take this away as I get prepared to talk about.
Oh, okay. Yeah, that's fair enough. Eclipses are amazing. We're so lucky. Basically an eclipse is it's my absolute favorite word, a syzygy. Right? It's the only word in the English language that uses 3 vowels that are all Y. SY, ZY, GY, and it's the alignment of 3 bodies in space. And so any syzygy can be called different things. It can be called an occultation. It can be called a transit. In our case, we call it eclipses because the idea is that when we look up in the sky, the moon and the sun appear to be the same size. Now, we know we're a brilliant society who knows that the moon and the sun are not the same size. The moon is much smaller, but it's also much closer. If you looked at the diameter of the moon is actually 400 times smaller than the diameter of the Earth. Sun, geez.
It's late, it's fine.
It is. The diameter of the moon is 400 times smaller than the diameter of the sun. But the moon is also 400 times closer, and that makes them appear to be the same size in the sky, about the size of a nickel held at arm's length. And because of that, for one, the second part is that the moon and the sun can pass in front of each other occasionally. Their orbit, or rather the Earth's orbit around the sun and the moon's orbit around the Earth cross. And when they cross, the moon can pass in front of the sun, casting a shadow on the Earth, or the moon can pass behind the Earth and the Earth's shadow is cast on the moon. In both cases, we get an eclipse, one much more rare than the other, and one much more harder to see than the other, but both beautiful.
Awesome. And the nice thing about solar eclipses too, so when the moon, so on most planets where the moon and their moons and the sun do not appear to be the same size, since ours appear to be the same size, it allows us to view the corona of the sun, and it's the best corona.
The what? Stop saying that word.
I know, I'm sorry, but this is the cool corona. This is the outer atmosphere of the sun. Since the sun is blocked perfectly by the moon, you get to see all the outer atmosphere stuff, which is very, very cool. And I'm sorry, Ryan, if you said that already while I was writing down questions.
No, I didn't. Absolutely, I did not. But I kind of laugh just because I do planetarium shows for a living, right? And so the last 2 weeks before all of us went onto social isolation, I was doing some shows and I was talking to some kids, and I'm showing them an eclipse, and I'm saying, oh, look, and that we call this the corona of the sun, which means crown. And all the kids did was laugh, coronavirus. And I was just like, oh my God. So that's why I laugh, is just because, as soon as we say that, it's suddenly this taboo word, or it's like, oh, we have to talk about it. No, corona means crown. It is the crown of the sun. Think of it that way. It's beautiful.
There's also a constellation, Corona
Borealis, yeah.
There we go. Thank you.
You were confusing it with Coma Berenices.
Yes, I was. You're absolutely right. And you called me out, and I'm ashamed.
Okay, you called me out on lots of stuff. I can't wait till it happens again, Jenna.
Someday. And now we're going to move on to talking about all of Sarah's stuff, because there have been several calls for it, and it is super awesome. So, Sarah, are you ready to talk about craters at great length?
I am.
Perfect.
Yes.
So Sarah, can you start? Actually, I know I told you I'd ask a different question first, but I want to ask this now. Can you tell me exactly what your PhD was in?
Yeah, I call it planetary geology. So I was in the Department of Earth Sciences, but I don't know much about Earth's geology or like Earth sciences. And before that, I did space science, so I call it planetary geology.
Cool. Okay. And so what were you no, I'm going to start with the question I told you I'd start with. Why did you choose the moon?
Yeah, this is a funny one. It was more like, okay, let me see what PhD program I can get into. And then let me see what my supervisor is working on, what projects she's got going on. There were a couple of options. There was a Mars one, but I told you the story of like how I got thrown off from Mars, of that whole like super Mars, big Mars thing, and it was not that exciting. So I just have beef with Mars since then. So I picked the moon. That was one of the other projects she was working on. My supervisor was Rebecca Gent out of University of Toronto. And she was on an actual space mission team that was, studying the moon. And I'm like, yes, I want that data before other people get to see it. And yes, I want to work on real time data and things. So that's how it started.
That's awesome. I love that it's like, I want this first. I want to know.
What Sarah's saying about projects is actually very common too. When you start graduate school, is you do what your supervisor is working on. And a lot of times we choose a supervisor because we're interested in the work that they do. But then once we get there, they say, hey, here's a couple of projects. Think about them, do a bit of prelim research, and see what you feel comfortable with and what you enjoy. So it's there is a lot of freedom to choose those kinds of things. And you picked a good one, definitely.
Yeah, and it was a nice mix of things that I was interested in and I had skills for. So I didn't want to do hardcore astronomy or observational astronomy or theoretical astronomy, and I didn't want to do engineering, but I did have some remote sensing experience. I wanted to do some mapping, some things that I could kind of apply to the Earth as well, and studying other planets just outside of, the aerospace engineering part, but actually being able to do science is pretty limited, actually. When you look into it, there aren't too many people doing planetary science in Canada, I don't think.
Well, I think you chose a good one regardless of what was available, and Mars can Go suck an egg.
Tell anyone I said that. There are a lot of Mars lovers.
I know, I'm sorry.
Suck
I
an
actually
egg moon.
Yeah, there you go. Hey. Everything's funny at 11 o'clock at night. Yeah, Mars is cool, but I mean, the moon's our closest neighbor. And I don't know, we've always had fascination with the moon, which is great. So what specifically did you delve into in your PhD then?
Yeah, so a question that we started off with was that we've got an abundance of data from the moon. So we've got the Lunar Reconnaissance Orbiter that's been orbiting the moon for over 10 years now, actually, just giving us data from the near side, the far side, all over. And my supervisor was on a team that was studying, it was called a Diviner instrument that takes temperature data from the moon. So we've got a lot of temperature data that tells us how rocky different parts of the moon are really. And the question we wanted to answer was, these rocky craters allow us to sort of figure out ages for craters. You might have seen, even when you look up at the sky, you can see craters with a telescope, even with the naked eye, but we don't really know how old they are, when they formed. We know when some of them formed, but not all. And trying to find an age for craters is actually very difficult. It's very time consuming. You're limited by data availability and quality. But now this new data set allowed us to get ages for a subset of craters in a much easier way. And that was to figure out, okay, how old are these craters? And what can we find out by having ages for these craters?
And what did you find out?
Yeah, so the data set allowed us to get ages for craters that are young, and in astronomical terms, young means anything younger than 1 billion years.
Wow.
Yeah, billion.
Not what I was thinking you were going to say.
Yeah. So I looked at these craters, I looked at these maps, and for probably the first 6 months or so, like any good grad student, I just, stared at the computer and manually mapped craters that looked young, that had a lot of rock around them. So whenever we have a crater form, it excavates a lot of rocks, a lot of large rocks that sit around the crater. And then over 1 billion years, they all get broken down into sand or regolith because they're getting hit by more and more stuff from space. So the rockier they are, the younger they are. So I mapped all of them, and we got ages for them. And we're like, okay, so now we have this new data set of all of these craters that are younger than 1 billion years old. What can we learn from them? And the recent thoughts, or I guess like the thought of it, was that the bombardment rate, so how often the moon has been getting hit by stuff, has been pretty constant recently. Whereas at the beginning of its formation, like Ryan mentioned, when the moon formed, there's a lot of stuff floating around in the solar system, a lot more bombardment, but then it sort of tailed off and everything's been constant. So we're like, okay, now I've got a bunch of ages. All I have to do is put them into different age bins and see if they all have the same number or not. If all of those bins have the same number, more or less, then that means that the moon has been getting bombarded at a constant rate. But to our surprise, we saw that that bombardment rate had actually increased by a rate of 2 to 3, so it had doubled or tripled in the past 300 million years.
Ooh.
Really?
Yeah. Had doubled or tripled in the past 300 million years. And we're like, that's cool. Because if you look at the Earth, and I'm not going to go into too much of that, but there's been a lot of activities happening in that era on Earth as well. And now you got to keep in mind the moon and the Earth are in very close proximity. So whatever that has happened to the moon has happened to the Earth as well in terms of history, because we're so close. But the Earth has an atmosphere, it's got tectonic activity, it's got weathering that erases a lot of that history. So understanding the moon would tell us more about the Earth's past. And in the Earth's past, in the past 400 million years or so, is when we went from single cells to multi-cells. A lot of things have happened, and it doesn't mean that one has caused the other, but there's been a lot of changes. So then, we got ready to publish our data. We're like, cool, we found something after like 2 years. It has doubled or tripled. Let's publish it. And one of our co-authors was like, just for fun, let's take a look at craters on Earth, really large ones on Earth, and see, if we see the same jump in both of them. And we're like, yeah, okay, definitely not. We don't have that many, craters on Earth. Everything's been erased, yada, yada, yada. And then to our surprise, they pretty much match each other.
Oh, that's cool.
Yeah, which was pretty neat. It took a lot of statistical work just to, because every time you do science, you have to be able to back it up a lot. But it was amazing that the two actually matched one another. So both the Earth and the Moon have experienced the same bombardment experience. And, things have been getting a lot bumpier lately.
That's really cool. And it's really neat to have, you mentioned that since the two bodies are so close, they would be experiencing the same thing. It's really nice to have that extra backup of like, the Earth did it too, guys.
Yeah.
That's so cool.
Yeah.
Do we have any questions?
I'm fascinated by it.
Yeah, this is super neat. And it's like well beyond my knowledge of all these things. So
yeah.
It's hard to picture. It's just hard to picture how intertwined our fate is with the fate of the moon. And right, we said earlier, right, we're 384,000 kilometers away, yet something that happens to the moon has also happened to Earth coincidentally. We're connected.
Yeah, it's very cool. Probably
Mercury and Venus too, actually. So Venus has got that crazy atmosphere, which makes it hard to really determine. But the super cool thing is that Mercury, the European Space Agency is actually sending Bepi Colombo to go around Mercury and collect data. And it's got a similar instrument on board as the Lunar Reconnaissance Orbiter. So in theory, we should be able to get very similar maps. So from temperature and how rocky they are. And, another grad student is going to sit there and map all of Mercury's young craters. And I'm looking forward to seeing those results probably in a couple of years to see if Mercury, theoretically, it should have experienced the same bombardment history, but that would be super neat to see.
Yeah. And
I hope that, sorry, Jenna, go ahead.
No, you go ahead.
I was just going to say, I hope that grad student has as much enthusiasm for their project as you do for the moon. So,
yeah, my word of advice to that future grad student is, as one of our co-authors told me, is sometimes you're sitting on a pot of gold and you don't even know it. So keep mapping those craters.
I love it. When you're feeling those days where you're just sitting and staring at craters for hours and hours and hours. You never know what you might find.
Yep.
We have some questions from folks. One of them is, when was the last major impact on the moon? Do either of you know? I don't know. I feel like, Sarah, this would be a thing that you might know.
On the moon or on the Earth?
On the moon.
We get craters on the moon all the time, like bombardments all the time. Some of the larger craters have been in the past few million years. Probably Tycho would be one of the largest, youngest, I would say. But if you remember, I think it was last year when we had the lunar eclipse, and there were a lot of telescopes pointed. They actually observed a real life impact crater happening by coincidence at the same time, right?
Yeah. Oh, it was so cool. It was like a little flash.
Yep.
And it's because everyone was watching at the same time that we saw it. Oh, it's so neat. I'm gonna go and try to find that video.
So that's what I was thinking of too. But I was gonna say, I guess it depends on what your definition of a large impact is, right? Is it an impact that creates a crater that's large enough to see from Earth with a small telescope, with a large telescope? Is it a certain diameter? Is it a certain size of impactor? Right. So those are things we kind of have to qualify when we say that. But Sarah, with Tycho, I didn't realize it happened within the last million years. So that, I think, would probably be the biggest in the past while, right?
Yeah, I think in the past 10 or 20 million years.
Wow.
Yeah. Okay.
Which is, astronomically like a couple seconds.
Yeah. It's fairly young.
I'm going to share my screen quickly. Just to show you guys the video of that impact. So what you're looking for, can you see the whole thing if I make it full screen?
Yep.
Yeah.
Okay, cool. Looking down in this area in about two or 3 seconds. So, little flash. Sorry, I was wrong. I'll go back and play it again. Down in this area. And they've slowed it down so you can see it a little bit closer.
Oh, yeah.
Little tiny flash. So yeah.
Tiny, gigantic,
yes,
small atomic bomb flash.
This is the thing, right? It's like, yeah, you're right. How do you measure what large is, especially when, Sarah, you've seen so many craters in your life.
Yep.
I imagine you've seen a lot more craters than most people.
Probably. I don't know if it's a good thing or a bad thing.
It's a good thing to have in your back pocket if ever someone says something to challenge you. You can say, well.
It's what it takes to become an expert.
Yeah.
You know, it's not always easy, but you get everything you need out of doing it again and again and again.
Mm-hmm.
Yep.
We have another question that someone sent in, and I'll check the Q&A there too. But that question is there a way for us to track bombardment? And we just kind of accidentally answered that with that video. Yes.
Yeah, the really cool thing now is that because we've got the Lunar Reconnaissance Orbiter going around the moon for 10 years, it keeps mapping the same areas over and over. And they actually have this thing where they compare maps of the same area over like months and years, and they can actually see where new impact craters have been formed, which is pretty neat. And I'm just going to share in the chat room for later the craters that I've mapped. One of our friends has actually, System Sounds has turned it into sound, so you can check it out later. I'll put it in the chat room.
I just went and checked out the chat on YouTube, where Eric Briggs has been having a time. He said,
"Hi, Eric."
he's Eric, not our media fellow Eric, who's wonderful. Yep. Eric, do you know Eric Briggs?
Yep.
Amazing. Okay, so he's been saying he wanted to know about Comet Atlas. I don't want to steer too far off the moon right now, but I promise you we'll get to it in a few minutes. Okay, Eric?
I want to know about it too.
Okay. Do I have any more? Oh, I haven't asked you my favorite question yet. What's your favorite crater on the moon?
Okay, I have two favorite craters for two different reasons. One of them is Tycho. And it was the time where I had to count a lot of craters and stuff, and I adopted my dog and I named him Tycho as well, because it's so bright and so pretty. And when you look at the moon, you can see it. It's like the one towards the bottom, which is really bright, and you can actually see the rays, which is pretty cool. And the other one is, for a more scientific answer, is Schrodinger Crater or Schrodinger Basin, which is on the far side of the moon, closer to sort of like the southern part of it as well. It's really large, but within it, like it's got one of, it's really cool. It's basically like a geologist's dream. If you could pick anywhere to go and pick samples from, it would probably be it, because you can get a ton of information, and it could be the oldest part, or like the oldest crater that has formed on, like it's within the South Pole Aitken Basin, which is like the oldest thing that would have happened on the moon. And that helps us give us like an anchoring point to what is the oldest crater or basin on the surface of the moon. Very cool. Anyways, yeah.
Good.
Schrodinger and Tycho. If I get a second dog, I might name him Schrodinger.
Oh, that'd be good. But then you have to make sure to explain to people why, because everyone will assume it's Schrodinger, like Schrodinger's cat.
Yeah.
And they can't have that. It's a dog.
So your dog's name is Tycho? That's amazing.
It is, yeah.
Oh, that's super cute.
Yeah. That makes me so happy. Alrighty, and that's, I think, all of the questions that I had for you. Do you have anything? From your PhD, what is one story that you've always wanted to tell that nobody's asked you about, or that people have asked you about, and you feel like you haven't had enough airtime with it?
I think one of the projects that I worked on that I don't talk about a lot is sort of coming up with a plan as to if we were going to have the next human missions to the moon, where we would land them, where we would land humans on, and how we would go from one place to another. So sort of actually creating a path that this is where you want to drive, because with the data that we have now, we can see how steep different areas are, how large the rocks around are, so you can figure out where to drive and where the best locations for sample collections are. And I feel like, yeah, that's something that I've been super interested in, combining science and future exploration.
That's very cool. And that leads us back to a question from earlier, which was, where did it go? Oh, do either of you know when the next manned mission to the moon is planned? It's Artemis, right?
It's supposed to be Artemis, but yeah.
Who knows what's going to happen anymore? The world is in flux.
Projecting at least 2024. Yeah.
Yeah.
And Canada is supposed to be making the Canadarm3 for that.
Yep.
Cool.
That's exciting. This is one of my favorite topics, mostly because there's a quote from Scrubs that I can reference. What are your either favorite or least favorite conspiracy theories involving the moon?
It's got to be that, you know, the whole moon landing is fake thing.
Yeah.
I mean, I get that a lot. Yeah, what can I say? I don't like it
after a while.
Yeah, but you know, again, with the LRO as it's orbiting the moon, it's revisiting sites that the Apollo missions went to, and you actually can see what us humans, well, not us, like the Apollo people, the Apollo astronauts have left on the surface of the moon, and the tracks of their rovers. And I'm like, look, science, data, it did happen. It was there. But you know, if they want to deny it, they will deny that too. But
there was a video game engine that was made that does this thing called ray tracing, right? Which basically creates paths of light beams. And one of the things that they did to test out this engine was they basically recreated the entire scene of the Apollo 11 landing. And one of the things that they found was that the only way that you could recreate the scene that you see in the photos exactly is if the sun was the source of light. Because of course it was. Because, right? So that's basically it.
That's funny.
And they basically gave more evidence, not that we need it, for why the moon landing actually happened. I have a conspiracy theory about the moon that I love.
What's yours?
As well, and that is that aliens are living on the opposite side of the moon.
Yes, I've gotten that one.
And they live back there so that we can't see them. So when we look at the moon, we just see this lovely little orb of nothing, and we're like, nothing lives there. But on the other side, there's an alien civilization science outpost studying us.
I had a phone call from someone about that once, and they were like,
kidding.
no, there's definitely aliens on the backside of the moon. We've never seen it. And I'm like, right, but we've sent satellites to the other side. And he's like, oh, well, they're underground. And I was like, oh, well, in that case.
Why didn't you say so beforehand, right?
Yeah. My favorite moon conspiracy theory is, as I mentioned, from Scrubs. And that was when the janitor said, I don't believe in the moon. I think it's just the back of the sun.
Oh my God.
Yeah. It's my favorite because it's like so easily disproved.
That's a good one.
Oh boy. There's a couple people chatting about various conspiracy theories in the comments now, which my intention was not to have us disprove all of the conspiracy theories, and I apologize. It's mostly to have a bit of a giggle. We could. The reason that the flag wiggles is because of motion. Like when you push something, it continues to wobble afterwards. It's not because of the wind. Because physics. That's right, Heather. Anyway, I think that was that pretty much all I had that I wanted to say. We are getting to 11:30 at night, so we are getting close to the end here.
We have not been talking for an hour. No.
Yeah, we have.
Oh my God.
It's fun when we all hang out together.
It really is.
Do we have any last minute questions before we wrap up for the evening? Okay, let's see. There's one long one that I haven't read all the way through. Oh, wow. Okay, that's a tricky one. What are the theories presently about the moon and how it may have influenced the evolution of life on the planet? Would we have complex life without it? Whew. It's a big final question here, Matthew. Whew.
No, I would think that Jupiter would be more important for the development of long-lived life, terrible phrase, but long-lived life on Earth, because Jupiter shepherds a lot of rocks that may have hit the early Earth and prevented life from grabbing hold. So That's my take on it. I don't. I'm sure the moon does help, but again, it's 384,000 kilometers away. It's next door. It's not down the street. It's not 150 million like the sun.
And we just talked about how everything that the moon is made of stuff that's come from Earth. So really, it's not giving us anything brand new. Whereas the stuff that's coming from Jupiter is bringing in all sorts of stuff like ice and water and fresh things like that. It's like a big sibling. I like that one. And Victoria from the Science Center is here. Hi, Victoria. And she has a great question because I love these kinds of things. Is there a fact about the moon you haven't shared yet and you want to, or a favorite fact? Anybody? Either of you two?
I'll share a fact that kind of answers another question that was in the chats as well about the brightness of craters. Another way that we can tell if a crater is young is for the most part if we can see rays around it. So Tycho has all these rays around it, and rays are usually a sign that it's a pretty fresh and young crater, because otherwise it would have been covered by ejecta and stuff from other impacts.
You know what my favorite moon fact is?
What's yours?
Gerard Kuiper, the guy who the Kuiper Belt was named after. When the first moon landings happened, he suggested that when the astronauts first set foot on the moon, it would sound like crunchy snow. Now, of course, there's no air, no atmosphere to transmit sound on the moon. But apparently, Neil Armstrong, when he was stepping on the moon for the first time, said he could feel the vibrations that felt like Kuiper's crunchy snow.
Oh, that's
cool.
That's my favorite moon fact.
I haven't heard that one before.
Oh, wait, one more fun moon fact.
Oh, God.
I think
Keep them coming.
Canadians were the first ones to step foot on the moon.
That was a good one. Yeah. Can you please explain for the people who don't?
So the foot, or like the landing parts of the Apollo modules that were setting on the moon with the Apollo 11 were actually made by Canadians. So yay! Yeah.
And I'm gonna
the legs.
Yeah. Sorry, Chris. Chris knows. Maybe he and Randy Atwood are tied for the people who know the most about the Apollo missions in Canada. It's something. I want to throw out my story, which Randy told me over a year ago, so I don't know for sure if it's going to be totally accurate. Chris, feel free to correct me. While Neil Armstrong, so while the astronauts from Apollo 11 were up there, and they were going out onto the moon, they had they had no bathroom, right? And so while Neil Armstrong was the first person to set foot on the moon, Buzz Aldrin was the first person to pee on the moon.
Now that's pee on
into a bag
in the module.
No, he was I think he was on the ground.
Oh,
okay.
Yeah, I'm not entirely sure. Yeah, I just want to clarify.
He was not peeing on the moon.
He wasn't directly peeing onto the soil of the moon. He was peeing into a bag that was attached to his leg, I'm pretty sure.
Yes, just want to clarify that.
It's very
important. Go hide behind that giant boulder and rock.
Yeah, just go see a man about it. Alrighty. There were a few little questions here and there. Things like, whose ashes are on the moon? Do either of you know whose ashes are on the moon? I don't.
No, a piece of the Wright brothers' plane, but not their ashes. I want to say.
Oh yeah. Chris answered it.
Charles Lindon?
Really, Shoemaker?
Oh no.
Shoemaker.
Oh, okay.
I did
Interesting.
not know that.
I remember hearing rumbles about it. Michael, if you know the story, and also thank you for joining us today. I really like Michael.
Just to clarify, a piece of the Wright brothers' plane is on the moon.
Okay, that's very cool. That's a neat, like, coming full circle on the human flight kind of thing. That's very cool. Alrighty, I think that wraps up pretty much all the questions. And it's also 11:30, and I'm sure you guys are all getting a little tired now.
I'll just link my website here. If anybody has more questions, I'm happy to. You can just find my social media from there. I'm happy to answer questions later as well.
Okay, cool. Thank you, Sarah, for joining us. I really
Yeah, thanks,
It was a
Sarah.
lot
That
of
was
fun. Oh my
Yay.
God, it was so much fun.
I'm so glad. This is if you're gonna stay up until 11:30 at night, you got to have a good time. So thanks everybody for joining us. And for a couple people asking questions, we do these every 2 weeks or so. And next time Jesse Rogerson will be joining us. And I say that hoping that he's 100% committed to that. Pretty sure he has.
I'll twist his arm.
Please do. Yeah. Jesse's also a friend of Ryan's too. He's from Ottawa and he does, can you get his full title, Ryan? Do you know it off the top of your head?
Yeah, he's the science advisor at the Canadian Aviation and Space Museum in Ottawa.
There we go. So he knows his stuff
and
too.
another ex-Science Center host.
Yes, we're having Science Center reunions every 2 weeks on a Wednesday. Yeah. So thanks everybody for joining us. Again, if you have extra questions, you can send them off to Sarah, or you can send them to Ryan at Astro in Action, or me, well, Eric, who works in our office at our Rask social media handle.
Jenna will get them. That's the important thing.
He'll just message them to me afterwards.
I'm gonna moon you one last time.
Oh, right. Thanks everybody for coming. We'll see you all hopefully in 2 weeks, and have a wonderful night, everybody. Oh, one last thing. On Monday, sorry, I promise this is the last thing, but it's moon related. On Monday, Randy Atwood's talking about the Apollo 13 anniversary. It's the 50th anniversary on Monday of the accident. So he's going to be talking about it. I will just quickly send out the link for that. No, I won't. It's on our website. It's ras.ca/COVID has all the updates. I just sent that out. It's on there under the speaker series. You can go and sign up. It should be a lot of fun. He knows a ton about it. So if you guys are interested in the moon or lunar exploration, that's a good place to come join us next time. Thanks, everybody. Thanks, Ryan. Thanks, Sarah.
Bye.
We'll see you guys later. Take care, everybody. Have a good night.
Night.